In this video, we're trying to determine where this infinite series lies in this hierarchy. So does it go there? Does it go there? Does it go there? Does it go there? Or does it go there? All right, so the way to kind of think of this is, first let's look at 1 over n to the fourth. So just the formula an, this piece right here. And now think about the fact that 1 over n to the fourth, since n is positive, and this is, you can see this is positive because we start at n equals 1, we go to positive infinity. So it's always positive, n is always positive. So whatever this positive number is, we're taking the fourth power of that. 1 divided by n to the fourth, you're dividing by more than you are dividing 1 by n cubed. Right? So that's the idea. Here we're dividing by more than we are dividing by over here. Right, so 1 divided by n cubed, you're dividing by a little less, so that's going to be a little bigger than 1 over n to the fourth. And so then if this is true, then the sum from n equals 1 to infinity has the same relationships, because these are always adding things, right? This is like 1 over 1 to the fourth plus 1 over 2 to the fourth plus 1 over 3 to the fourth, and so on. Yeah. And so we have that. So we know that 1 over n to the fourth is either here or it's there, right? Because if it's here, then it's actually still less than. And this relationship that we found right here still holds. So now we got to kind of figure out which one of these two spots, here or here. All right, now remember that exponentials grow way faster than powers. So dividing 1 by 3 to the n is going to be way smaller than dividing 1 by n to the fourth. And so then again we can do make the sum there, like so. And so then we know that, in fact, the answer is right there. Now, this sort of reasoning may be a little too ambiguous for you. And so if that's the case, then let me show you another way you can kind of think about it. Our intuition, where we were saying dividing by more, told us that 1 over n to the fourth went to infinity slower than 1 over n cubed, right? Because of this dividing by more idea. So to figure this out, you can also, so another way to do this algebraically is you can say, you can do this thing where you, an bn so if you know that an goes to infinity slower than bn, then you know that 1 over bn goes to infinity slower than 1 over an. So using this same sort of idea here, right? And this goes both ways. So that's what this double arrow means. So our idea was we had 1 over n to the fourth, right? Our intuition told us that that was less than 1 over n cubed. Well, if that's true, then that means that, and notice how they switch, right? That means that n cubed goes to infinity slower than n to the fourth. And this we know is true, right? If you think about it in powers, right? 2 cubed is always going to be less than 2 to the fourth. 100 cubed is always going to be less than 100 to the fourth, right? So that's the way you can kind of, so we know, so that's how we got that one. And another, and looking at the other side, we were saying that 1 over 3 to the n and 1 over n to the fourth. So doing the same thing again, this would tell us that n to the fourth goes to infinity slower than 3 to the n. And this we know as well, right? Powers go slower than exponentials. All right, so this verifies that we were doing the right thing.